It is, remember, y is equal to a plus bx, right? So the first thing you need to do is identify the slope, and then you can identify your fixed costs, and you'll be fine. How do you find the slope? Delta y over delta x, which is equal to y2 minus y1 over x2 minus x1, right? So this point is approximately, let's say, 42 and 700. So let's make y1 700 and x1 42. And this point is approximately 98, you want to say? 98 and 1400? Okay? So you now have the data points. 98, 1400. In algebra, that would be 98, 1400. And 42, 700. So what do we do now? Subtract 700 over 46. And what does that come out to? Somebody with a calculator? 56. So what does that come out to? 12.5. Okay. That says that your variable cost is $12.50 per unit. Now we have to find our fixed cost, right? Well, we now know what B is. So we have Y is equal to A plus 12.5 X. How are we going to figure out A? One of the 2 points, either one. So let's make this one smaller numbers to work with. They'd give you the same answer. It doesn't matter which one you plug in. 700 is equal to A plus 12.5 times 42. And can somebody solve that for A for me? What's that? 175. So A is equal to 175. So your equation is Y is equal to $175. That's your fixed costs plus 12.5 times X. So for each unit or each machine hour you have, you will increase your labor costs by $12.5. Okay? That's the high-low method. Simple, straightforward. What are some problems with this method? It might be nonlinear. Hopefully within the relevant range it is, but you don't know. Outliers. It's very dependent on outliers. If in month 8, for some bizarre reason, it was way down here, you have a completely different line, a completely different function, even though everything else is kind of up in here, just one bad month, or one incredibly good month, it doesn't matter, or what expensive month, either way, your outliers totally affect it. Because it only includes 2 points, and those points, at least the way we've defined it, is your lowest and your highest. You always have the option of casting aside an outlier. You know, there are no hard and fast rules. This is just what we did. This is a picture that just shows the difference. If 8, rather than being down there, were up here, 1 month, one change, totally different situation. You guys want to practice one? Well, you know how to do it. I'm asking you. You were one of those who raised your hand to say you could do it before. Someone who couldn't do it before, you want to practice one? I'll ask the question a different way. That was an unfair question. You're not going to get out any earlier whether you practice one or not. Do you want to practice one? Still no answer. Okay, we'll move on. You do have to know how to do it. Practice on your own. What are the pros and cons? Requires less effort than regression analysis. I don't believe it. They both are done by computers very easily. Provides a reasonable cost that you can use. So a pro is it's reasonable. It's not bad. The cons, you're using two subjective points that could be subject to outliers. And frankly, it's not as accurate as regression analysis. So let's talk about regression analysis. It's called least squares analysis, right? Have you heard that term? Least squares